Figure 5 shows a circuit diagram. Right, so we have this is a fuse right here. We have a battery, and we have these 1, 2, 3, 4 resistors as well as a switch. Now it says, now use the circuit diagram in figure 5 to determine the total resistance in the circuit. So if we examine this circuit, what we have is we have our battery, we have this resistor in series, right, with a switch, which is in series with this one. So these two resistors are in series, because if we look at how the current will flow, current will have to flow through this, and it will flow through this. So these two are in series. But if we look closely now, these two are in parallel. So to find the total resistance, we're going to actually find the equivalent resistance of this branch, this parallel branch. And then once we have done so, we can now consider a new circuit with 3 resistors in series and then calculate the total resistance. So first, I'm going to calculate the equivalent resistance here. So to do that, I'm going to first scroll down here. Right, and I'm going to say first of all that the equivalent resistance Req due to this parallel branch, since we have 2 resistors in parallel, I'm going to consider the product over sum. So I'm going to say R1 times R2 divided by R1 plus R2. So I'm just considering these 2 resistors, R1 and R2, arbitrarily. So now, after that, I can just fill in these values. So I'm going to say R1 is 4 ohm multiplied by 6 ohm divided by 4 ohm plus 6 ohm. Now, what this is now, I will now apply math here. So I'm going to say 4 times 6 is 24 divided by 4 plus 6 is 10. So therefore, the equivalent resistance due to the parallel branch would be 2.4 ohms. So now I'm going to consider a new circuit now with just the resistors, the 3 resistors in series, because what we did was we actually calculated the equivalent resistance of this branch, so we can consider a single resistance in series with these 2. So I'm going to say my circuit now will look something like this. So I'll have the fuse right here. Right, then the battery. I will have my first resistor here. Switch. Then this will be my second resistor here. And instead of the parallel branch, I will just have a single resistor that has the same resistance as what we just calculated. And this would be my circuit. So again, we know that this one was 3 ohms, this one was 2 ohms, and we just calculated this one a while ago, and it was 2.4. So we're going to say this is 2.4 ohm. So to calculate the total resistance, then we're going to say RT now. Since we have all resistors in series, we're going to say RT is equal to R1 plus R2 plus R3. So now R1 is 3 ohm, so we say 3 ohm plus R2, which is 2 ohm, plus R3, which is 2.4 ohm, so 2.4 ohm. Now when we take the sum of this, now we say 3 plus 2 is 5, plus 2 is 2.4, I should say, is 7.4 ohm. So the total resistance in the circuit would be 7.4 ohm.